I have finished cleaning up and degreasing all of the components of an axle with a cup and cone type bearing on it. I'm ready to fit them back into a hub. In this video I'm going to show you how the components fit and how the distance between the cones are set correctly so that the axle in the hub is neither binding nor has it any kind of play. Fairly straightforward. Before I make anything greasy, I'm going to show you the surface condition and discuss some considerations here for assembly. Let's take a look at the cone surface condition first. The bearing balls will be placed here and will run here on this surface here of the cup. There. So where it's shiny here, this is exactly where those bearing balls run. Anything else? I'm not saying doesn't matter, but matters a lot less. For example, you can see some serrations or some stripes on the edge of the cup, completely irrelevant to the operation of the bearing. Okay? You need to look at here, the contact surface right there where the tip of the screw is touching. I don't want to scratch the cup too much, but it's a hardened piece of steel and this side is very fine. Inside the hub where the axle goes through, there is some grease. I really don't care about that, nor will I clean it up. The other side also looks good, with a little bit of corrosion might be visible here between the steel cup, hardened steel cup, and the aluminum flange here at the edge of the cup. Really irrelevant or doesn't matter. Now just as the light reflects off the cup, it looks like maybe there's a bump on it or some kind of surface unevenness. This is a classic bicycle and is not going to be raced in the Tour de France. This is fine as is. The condition of bearing balls, dust shields and cones are also fairly straightforward. The bearing balls look shiny, they don't look pitted, they roll easily when they are clean. They're fine as they are. Condition of the dust seal, as long as it's not too much out of round and is flat without being bent up, bent in, whatever, its shape is close enough. On the cone surface here, you can see the cone. This one is black, this one is shiny. This has been replaced by somebody previously. The original cone, the factory original cone, it's the rolling surface on it is gouged out or pitted, has corroded away previously. Again, I'm not trying to set land speed records with this bicycle. If this is the last cone on earth, it's fine. If you want to replace it, absolutely go for it. If in your market the component is available, absolutely go for it. If it's not, it's good enough. This surface texturing or this surface pitting is only going to affect your speed minimally because the bearing balls roll over it. Yes, they will kind of go up and go down a little bit. It's going to be a little jittery, but we're talking, look at it, it's microscopic. Alright, so it's good enough, especially for the purpose that I use it for. The new cone looks pretty flawless as is, never been subject to serious corrosion. Alright, next item or next consideration in the assembly is the lock nut to lock nut distance. Obviously the cone, the washer with the tab, I'll show you just one more time just in case you missed it in the previous video, what this tabbed washer here looks like. This is what the tabbed washer means. So this sandwich of these three components on a quick axle hub, or There is the quick axle for it. So quick axle is going to go through this, and we'll clamp it to the frame or to the fork. I have just some show and tell forks here. This lock nut to lock nut distance is critical. When everything is assembled, the lock nut should be tight against the washer, should be tight against the cone. This should be one solid unit on one side, and this will be one solid unit of these three components on the other side. But when you're done, the number of threads showing on one side should ideally equal the number of threads showing on the other side. Okay, I hope that makes sense. And let me get you a visual here. For all intents and purposes, you don't want more threads showing than the thickness of the fork spar. Let me explain this one. Here is the forks. The fork ends in this C-shaped spar, into which the axle gets mounted like so. I'm gonna get you a sharper image. Nice. Something like this. The thickness of this blue frame material should not, the thread length here on the axle should not be more than the thickness of this metal here, because what the quick axle does, it locks the two ends, or the two ends of the fork together with a little bit of flex, like so. I'm not really straining, I can still talk without making an effort. Okay, it's really easy to do this. The quick axle will gently do this, and this is gonna be important, that when you set and tighten, actually I tightened this half, I tightened this sandwich of these three components together, they get tightened to a position where the number of threads showing in this case is 3.5 turns, because it fits into the fork's end, and the 3.5 turns does not exceed the thickness of the fork spar here. That makes sense? If the axle was longer, then it's never going to be secured in place. This needs to exert a clamping force to clamp the axle in place. I hope that makes sense. And why at the moment there seems to be this gap here is because this is loose, its position is unknown. It cannot be pre-tightened or pre-placed too much. So that's why, let me show you, 3.5 turns on the thread. The thread, as you can see, it's being cut here, starts here. So from here, given this light, you can see we have one full turn, and then a second one underneath there, and then a third full turn underneath. 3, maybe 3.25 turns. On the other side, we will end up with the same once this is set. This distance here is set. It's dictated by the cup to cup distance on the wheel, and it's gonna be, with the correct size of bearing balls, it's gonna be just right. Okay, I just wanted to show you this geometry. In terms of tools, this is all that's needed. A bicycle wrench with a 13 mil, a 13 mil cone wrench, which is skinny like this, and a 17 mil for the lock nut, like so. They will lock together in position like so. So that's what I did on this side. 12 mil, 17 mil, force them together. They are tight and they are at the correct place. The other side will get tightened later, not much later. I'm gonna take them off for now, because I'm ready to make everything greasy and messy. What gets greased is the cup side. I have here, in this instant, this is some Yamalube. Yeah, Yamalube marine grease. It is a thicker type of grease. It's not premium axle or premium bearing grease. Okay, that's way too much grease on my hand, but it's okay. And all I'm doing is I'm buttering up this cup, making it look like it's thoroughly greasy, but not smeared on the flange where it doesn't need to be greasy. The flange on the hub is also aluminum or aluminium, depending on the market you're in. And only the steel, that's a little too much. Only this steel cup needs to be greased. Its edge, whatever, everything. Alright, so that's how this looks like. One side and the other side on it. Okay. Now, I just want my fingertip just slightly greasy, just about like so. And I'm done with that pointer. And I'm gonna press these bearing balls in place, or just put them in the grease like so. They are buried in the grease and they stay put. So that's one. 9 of these go in each side. And I want to do it ideally right here over this tray, because I really don't want to look for these tiny 5/32 of an inch or something like that size tiny bearing balls. Once they roll around on the deck, they really are miserable to find them again, and I really don't want to do that. So assembly takes about exactly as long as you see me do it. Of course, I've done it a few times, so your assembly time might be longer, say an hour, whatever. It's a good start. This type of bearing, this cup and cone type bearing, is not waterproof. Okay, one of the balls slipped down and I'm gonna have to, and it's coming out on the other side. It's falling through, suspended in grease very slowly. So what I'm gonna do is, I need this long skewer. I'm taking off this nut from the end of it sometime today, and the springs, because I don't want to lose the springs, and I want to get the bearing ball out at the other end. Yep, like that, and press it in place here. So on this side I have a set of 9 bearing balls. I want to put a cap over them. I want to fill the cap lightly with grease, because I don't know if I finished this sentence, but so this type of bearing is not watertight. Shimano still in 2020 makes Dura Ace wheels with cup and cone type bearing, which has a has a different geometry than this one has, but it's still cup and cone. It is different in quality, in terms of quality, so that's good enough there for one side. Flip it around, place the balls in on this side. Bury them in grease. Make sure they absolutely don't go anywhere. That's why I'm using this stiffer grease, not premium bearing grease. It's also quite hot, and I don't want the grease to run or to release the balls. There, we're gonna bury these in grease, but still being able to see them. Like so. Because I want to verify that they are indeed all in place. If one of them moves out of place and starts rolling down in the middle of the axle, in this hole where the skewer goes through, I really want to be able to see and see through here to verify that it's not happening. So right now I have filled this side and the other side, and I have one extra bearing ball in the tray. That's not normal. So obviously one side is missing one, and the balls need to be pressed slightly closer together on this side, I believe. Yeah, and just a little bit. Alright, so that spacer is pressed in place well, and this one is also, well, I'm not happy with this spacer, or not spacer, this dust cap. There, now I'm happy with the dust cap, so it's nice and even, whatever. Now I need to wipe my hands, and the rag is behind you. Oops, sorry about that. We're almost done with putting the cones and the axle in place here, and setting this distance is really straightforward. This is the painful part here. So this cone can go on either side. We're gonna butter it up. This is the lame side, or whatever, the worst of the two cones. Just gonna assemble it like so, make everything greasy. Yeah, because moisture is gonna be a problem. And put it in on one side like so. So far so good. Flip it around. I can still verify and make sure that all of the balls are still in place. And I can grab the other cone, also make it greasy on its running surface, like so, and of course spin it in place. So this is where it's important that one side, this side here, is firmly locked in place with the wrenches previously, and it stays so, and this side with the cone gets adjusted, because if both sides move at the same time, it's gonna be tragically not working out for you ever. You're never gonna finish this installation. So right now this cone has been tightened to such a degree that it, of course, the axle turns around, but it has a little bit of a play. Not good enough. This cone needs to be tightened, maybe a quarter turn. Still not good enough. Maybe a little more, little play, maybe just a tad more. That's pretty good, but it's also binding. I'm gonna back it out just a little bit. Also, when you back out the cone, the axle turns with it, so one side, one hand has to hold the axle in place and the other one manipulate the cone only. So find a spot where it doesn't have any rattling, and thereabouts. Maybe if I turn it a little more, it starts to bind. Okay, I'm happy there. Grab the tabbed washer, put the lock nut on it, and tighten the lock nut while holding the cone in place so it doesn't rotate out of this position. So I'm gonna just start the lock nut. I might still adjust the cone microscopically while the wrench is on it, but I'm gonna need 2 clean hands, which I don't have, to handle the wrenches because I don't want to make anything messy. From here on, once these 2 are tight, it's gonna be perfect.